All right, guys, so today we're working on lesson 17. It says we are doing this paper instead of the workbook from lesson 17. When we finish today, fold this paper in half and put it in your workbook so that you do not lose it. So again, what I would do is right by unit 2, lesson 17, I would take this paper, fold it up, and then put it in there instead. Okay, it says, Warma, what's wrong? So Priya is solving this system, but she got an answer that doesn't make any sense. What happened? Okay, so if we take a look at the problem, we'll look. And the first thing that we would need to do, right, is we would take the equations y equals 3x plus 5 and y equals 3x plus 2, and we would do a little bit of substitution, right? So what that means is because it says y equals this box right here, what I could do is I could take this box, bring it into the second equation, and right here for this y, what I would do is I would just cross off this y, and I would put that box there instead, right? So I would put instead 3x plus 5 into that spot for y. Okay, when we do that, we would get something that looks like this. So 3x plus 5 equals 3x plus 2, right? And if we take a look at this, the steps that we would do, first is we would try and cancel the smaller variable, right? Well, if we take a look at these are both the same variable. So we could choose either one of them. And in order to cancel it out, what we would do is we would subtract 3x from both sides. When we subtract 3x from both sides, what would end up happening is these two things would actually cancel each other out. So the only thing that would be left is 5 equals 2, right? But 5 doesn't equal 2. So what happened? In this, what we would say is 5 doesn't equal 2. So this doesn't have any solutions. Okay, that's kind of what we would do there. On the next part, now we're going to go on to 17.2. It says how many solutions? So what we have, it says the solution to a system at the intersection of two lines, right? That is where we would find the solution to two equations. But what if the lines never intersect because they are parallel? Okay, so if we take a look, I got some stuff here. What I did is I made a little graph. It would be really helpful if you drew a graph like this. The key to this graph, though, is drawing two lines that don't cross each other. So what I said is if two lines never cross each other, then they never share a solution, right? So then I would say they have no solutions. So take a minute, copy this down, make sure that you have it. On the next one, it says, what if the equations are equivalent and they intersect everywhere because they are really the same line? So what I did my best here, and this is the hard part to do, is you want to draw a graph that has two lines that you can tell are right on top of each other, right? I use two different colors to make sure that they're right on top of each other. And what we would write is we would say if two lines are right on top of each other, then they have infinitely many solutions. So infinitely many solutions means that they share a ton of different solutions. Those two lines are right on top of each other. And it says, just by looking at the following system, can you tell how many solutions each one has? All right, so take a minute and take a look at those equations. If when I look at them, some things that I notice, right, is that these two equations right here, they both start the same. So that's why I circled these two things. They start the same, so they both have a y and a y. They have a 5x and a 5x, but they end differently, right? So this one has a 7 and this one has a 3. If that's the case, I would say that they have no solutions, right? If I graph those, there would be two lines that don't cross each other. But if I take a look at the next one, I can see that if I take everything in this first equation and multiply it by 2, it'll turn into the second equation. If that's the case, then I would say that these two things have infinitely many solutions. And if you want to write infinitely many solutions but keep it short, you can just write IMS. That is the same exact thing. Okay, and it looks like we're going to have to move on to a part 2.